recorded. Feel free to drop off and we will upload the meeting to YouTube. And you can view it from there. So in this meeting, we are doing it different. We are going to go through the meeting. Poornima will do the presentation, and then we will take questions at the end. But if you have questions, feel free to drop them in the chat box or save them until the end. If you drop it in the chat box, I will try to compile those and ask at the end of the talk. And for others, other than the presenter and the organizers, if please consider turning your camera off during the presentation, just because it makes for a better user experience, especially on the recorded video. So we'll ask questions at the end. So today's agenda is, obviously we are having the welcome and announcements. This talk will be recorded and will be uploaded to YouTube. I will provide the link shortly. And this talk is so a few things. I'm really looking forward to this talk. Poornima is our presenter today. Poornima will be talking about REST versus gRPC versus GraphQL, which is kind of some of the technologies in use today for building APIs. And I can, read from this description, but I think Poornima will do a better job when she starts the talk. And, we would like to know, first of all, why she's doing this talk and, why is it so important to distinguish between these three. So hopefully we'll get a good understanding of this by the end of the talk. And today's meetup is being brought to you by the Orlando.NET user group, or OneTag as we call it, and the Orlando Code Camp board. Orlando Code Camp got canceled in 2020, March 2020, because of COVID, and has not been back, but we are in talks to bring it back maybe later this year, early next year timeframe. Then that'll be an in-person event. Also, Orlando.NET user group, if you're a member of that, look forward to announcements of the in-person meetup, which will be starting not in the distant future. And these are some of our organizers. So the resources, it's extremely easy to find the resources for Orlando.NET user group. So you basically have to remember OneTag.NET, and then for Meetup, Twitter, Facebook, YouTube, LinkedIn, you basically add the name of the service at the end. So we'll also be adding other links in there shortly, like the GitHub link and others. If you want to get in touch with us, best place to do it is either ping us on Twitter or email us at board@onetag.net. Like I said, upcoming meetings, we will announce those shortly. So if you are part of our meetup page, if you have not joined our meetup page, I highly suggest that you do. And if you have already joined our meetup page, then just look forward to announcements. We will, for the foreseeable future, also continue having virtual meetups, but we will be we're going to start doing some in-person meetups also. So definitely look forward to all of that. If you have any community announcements, please feel free to bring those up right now. Any projects, any events, conferences, talks? If not, I'll move forward. So I'm really looking forward to today's talk. I basically got in touch with Poornima through the Women of .NET page. If you haven't checked that one out, it was created by Leila, who's a former speaker at OneTag. And it's really good resources for getting in touch with women who are doing great work in the area of .NET. So what attracted me to this talk was the fact that this is very timely, and there's a lot of learning we can take from this particular topic. Introduction: Poornima herself is a freelance .NET developer, Microsoft MVP, and Umbraco MVP. So when you get started, Poornima, please tell us about the Umbraco part. That's really interesting. And she has obviously all the passion to learn about new technologies and keep herself up to date. I would also love to know the Carnatic music, the Indian classical music that you just started on again. Talk about that journey. And you have a little kid, and you spend your time reading books, cooking and watching movies, and you can follow Poornima on Twitter over there. So with that, I am going to hand it over to Poornima, and I am going to turn my microphone and camera off. Good luck, Poornima, and if there are any difficulties, I'll chime in. If not, we'll just take questions at the end.
Thank you, Santosh, and thank you for having me as a speaker today. I know it's early morning, late night for many of the attendees, so thank you for all who are attending today as well. It's a great privilege to be a part of the meetup group today. So without much delay, let's get started. I'm pretty sure Santosh introduced me very well to the attendees. Thank you, Santosh, for that. But let me do my due diligence as well. I'm Poornima Nayar. I'm a freelance .NET developer, and I'm talking to you from Berkshire in UK. And we have almost miserable weather, and it's 1 p.m. here. I'm a Microsoft MVP for developer technologies. And as Santosh mentioned, I'm a 3-time Umbraco MVP as well. Umbraco, for those who don't know what it is, it's a .NET-based open source CMS. And I've been associated with the community for about 3-4 years now. I do a lot of contributions, not just code and documentation, talking about Umbraco, writing articles about Umbraco. At one point, I was also a part of the community team that's currently now in place as well, but the members have changed. So I was part of this community team who was responsible for reviewing the pull requests that comes into the core code from the community. And having said that, Umbraco has a lot of contributions going on as well. So I've been an active community member for Umbraco for the past few years as well. That's the work part of me. Non-work me, I'm a mother. I have a 7-year-old daughter. It's school holidays here, so she might come barging in any minute, actually, during the meetup. In fact, she does that when I do my evening meetups as well. I read a lot, so not like fiction work. I love reading that. Currently, I'm reading a biography called A Princess Remembers, which is the biography of Princess Gayatri Devi of India. And I need a little bit of disconnect as well from the entire world at some point. Being a developer and a mother, it can get overwhelming. So I restarted my journey with Carnatic music vocals. So it's about 3-4 years that I've been training now. So you never know, you might actually be one of the attendees at my performance as well. Let's wait and watch what happens there. And that's my Twitter handle, should you wish to connect with me. So my topic for the day, REST, gRPC, and GraphQL. It's a point of debate among developers. We can see all sort of blog posts and articles and even tweets saying, hey, this one is the best, this one is not really nice. I'm not going to say use REST from now. It's all about gRPC or GraphQL, all sort of tweets and articles. But my point today is not about a debate. I personally am closer to the REST world, or rather the HTTP API world. So it would be unfair for me to actually talk about what is the best. But I wanted to learn or understand the basics, or maybe a little bit more about each of these API patterns, which is the reason I wanted to do this talk in first place, and the learning has never disappointed me. I hope you can take away something from today's topic as well. But comparing these three would be like comparing apples and oranges. So I'm not going to say which one is best. We will actually compare them, see what each API pattern is all about, understand the basics. We'll go through a comparison. We'll talk about use cases, test how you can test your APIs, tools for that, etc. And we need a common ground to actually compare the three API patterns. So we are considering a fictitious user database. So it's totally fictitious, so nothing concerning GDPR there. It's a totally fictitious user base. We will talk about how the APIs might look like if we are to perform CRUD APIs or operations on this user database. Then we'll think about extending this. We have a user database. Why not we extend that to like a fictitious social media platform again, where each user has stories and comments, and how the API in each of these three patterns would look like on that extended platform as well. So let's get started with gRPC. gRPC is a modern open source high performance remote procedure call framework. So gRPC is a flavor of RPC or remote procedure call framework. And the definition of remote procedure call goes like this. A remote procedure call is when a computer program causes a procedure to execute in another address space, which is coded as if it were a normal procedure call without the programmer explicitly coding the details of the remote interaction. There are three key things to this. Execute in another address space, but coded as if it were a normal procedure call. So if I'm the developer, I am invoking a function as if it was a local function. But in reality, that function is getting executed in another address space, another server or somewhere in the cloud, whatever it may be. But the programmer, that is me, I don't explicitly code the details for the remote interaction. So there's location transparency. The system hides where the resource is actually located. So basically, in simple terms, it's me as a developer invoking a function across the network, but without actually knowing where the call is going. That is remote procedure call. Calling a function locally, but it actually resides somewhere else and executes somewhere else. Remote procedure call is not something new. RPC, there have been different flavors of RPC since 1970, and gRPC is one flavor of RPC. And the basic functionality or the nucleus of gRPC is functions. You call a function on another server as though it was a local function. So you can call it procedure or function call or subroutine call, all such names for that. Now, how does the server and client communicate with gRPC or RPC? We have client server to begin with. So we have the client functions, that is my program. It calls the client stub. A stub is nothing but a piece of code, which is at its simplest used for converting parameters passed between the client and the server. And the client stub uses a process called marshalling to pack the parameter. The call then transfers over to the RPC runtime on the client, through to the server stub. The server stub, through a process called unmarshalling, unpacks the parameters, passes on the call to the server function, and the server function is where the function actually executes and produces an outcome. And that result traces back through to the client program through the same way it went in, but in the reverse manner. So this is how RPC works in a nutshell. Talking about gRPC in particular, it's Google's implementation of RPC. It's pretty new to the market. It was initially called Project Stubby, and it was made open source and called gRPC in March 2015. And when Microsoft came out with .NET Core 3.0, that's when we started getting official support for gRPC in the .NET realm. gRPC supports API development or contract-based API development. And one thing what comes to my mind when I talk about gRPC, the first thing that comes to my mind is design for HTTP2, because gRPC makes use of all the features of HTTP2, like some of the things that I can think of: request multiplexing, streaming capabilities, which are HTTP2 features. Talk about gRPC, we also need to understand what protocol buffers are. So protocol buffers are Google's open source mechanism to serialize structured data. So they've gone with something called protocol buffers, which is very different from JSON or XML. It's language neutral, platform neutral, and extensible. But if you have played around with some of the IoT devices in the Google realm, again, you would come across the term protocol buffers there as well. With protocol buffers, data is structured as messages. So this screenshot or the little snippet that you see is an example for a message. So messages go in from client to the server and messages come back from server to the client as well. So in this case, it's something called a person reply, and it has got 3 fields: first name, last name, and a Boolean field, has a pet unicorn field, and each field has a type and a number attached to it as well. So with messages, they are basically a record of key value pairs, and each item in the message is called a field. Um, Unlike JSON or XML, where the field name is used as a marker to serialize structured data, protocol buffers use the number. So this is one reason why the size of protocol buffers are low. So the value of the first name is not serialized against the first name field name, it is serialized against that number. So when you think about versioning or changing the message format, say when you change your service, this number is of great importance as well. With protocol buffers, messages are transmitted in binary format. That's again one of the another reasons why the size of the messages are so low with gRPC. Talk about protofiles. This is what the contract of the API is. gRPC is contract-based API development, and protofiles are where you specify the contract of the API. So typically in a protofile, you would have the definition of the gRPC service. You would have your procedures. So it is one definition per protofile, which is like the best practice, but there can be many, many procedures in a single service definition. That is one protofile. And the messages that are sent between the client and the server, they also form a part of the contract. That is a protofile. So this is a sample protofile I have from the Visual Studio out-of-the-box gRPC template. First of all, we have the syntax, which is Proto 3. I believe this is the latest syntax for protofiles, and this is a much simplified version compared to Proto 2 as well. We have an option called C# namespace. So gRPC, with the tooling that gRPC provides us, it helps with some code generation. And the C# classes which are generated for you is generated in the namespace that you specify here, in which in my case, it's the gRPC demo namespace. There is also this package option. I understand that if you don't specify a C# namespace, this greet would be the namespace against which the C# classes will be generated using the gRPC tooling. Then you have your service definition. So that the greeter is my service name here. And it has got a single remote procedure called say hello, which accepts something called hello request and returns a hello reply. And then finally, we have the messages. The hello request is what goes into the server, and the reply is what comes out of the server. I told you that there is some tooling which generates the code for you. So what happens behind the scene is for each of the service definition that I have, a corresponding C# class is generated on the server. So the corresponding C# class will have the naming convention, the service name, dot service name followed by the word base. I don't know whether you can actually change this naming convention, but this is how it generates out of the box as default. These are abstract classes, and each of the methods in my service definition gets created as virtual methods, which means you can create an implementation of this C# abstract class and provide overrides to implement your own service methods. And the messages that we specify as a part of the protofile, they get generated as POCOs as well, plain old C# objects. And each of the field, the tooling takes care of understanding what the return type of each field is and mapping it to the corresponding .NET or the C# type as well. This is on the server side. There is code generation on the client side as well. So for each of the service definition that I have, it generates a client, again, following the naming convention, service name dot service name followed by the word client. And it is using this client that you actually speak to the methods on the server as well. There's a client stub getting generated for each method, and that client stub then talks to the server. And all this code generation is controlled from the CS_proj file on your project. So you have references to your protofiles using the protobuf reference. And there's an attribute called GRPC services, which if it's set to the value of server, generates server-side code. If it is set to client, it generates the client-side code. It can be set to both, in which case it generates both server-side and client-side code, and that's the default. If it is set to none, no code is generated. I think one of the typical examples of sharing this protofile across your project is by using NuGet packages. So you have your protofiles created as NuGet packages and then installed into the project, generating the server and client code as your need be. Now, how does the API look like? So we are talking about this fictitious user database, and I want to perform CRUD operations on it. What would be the methods like? I would have say single service to get all the users, get a user by the ID, say create a user, update a user, delete a user, etc. And each of these would have their own request, that is the message going in and the message coming out from the server. As you can see, it's very action oriented, very purpose built, like get me this or do this. It's very action oriented. And if you want to extend this further with users having stories having comments, if you want to get the latest activity for a particular user, again, you would have purpose-built methods or functions for that, like get stories for user, get story by ID, top user stories, story comments, latest activity. So it's very action-oriented, very purpose-built, in my opinion, which gives it that tight coupling feeling. So if you build something for one purpose, you're using it for that purpose kind of feeling. With gRPC, it's important to talk about the gRPC methods or modes. Till now, we spoke about unary, where the client sends in a single request in its entirety and the server responds back with a single response, single message in its entirety. We also have server streaming, nicely taking advantage of the HTTP2 functionality. So with server streaming, client sends in a single message in its entirety, but the server gives you a stream of messages as a response. With client streaming, it is exact opposite. Client sends in a series of or stream of messages into the server. Server sends back a single response in its entirety. You can have bidirectional streaming as well, where the client streams a series of messages and the server sends back a stream of messages as well. And the order of the messages are taken care of for you by the system itself. You also can have metadata with gRPC. You can have request headers. You can have response headers. But we also have streaming functionalities with gRPC, which is where response trailers come in. So response trailers are served after the response is complete. So if your stream from the server say stopped right in the middle and errored out, you can potentially send the reason for the error as a response trailer. You can send in the number of messages that that the server sent out as a part of response trailer, and so on. There are plenty of use cases for having response trailers as well. So this is one extra bit of information that you would get with the metadata. Now, some of the advantages and disadvantages of gRPC are lightweight messaging because of protocol buffers being in binary format. It's high performant. There's built-in code generation. There's streaming options, which is quite unique to gRPC. And of course, it's scalable. If you want to load balance, you can do that. All of the functionality that you would expect to have for an API like microservices, all of that is available with gRPC for you. And I believe that there is also support for HTTP 3 or Microsoft is starting to support gRPC for HTTP 3 as well going ahead, which is a huge thing again. But on the negative side, we have a tightly coupled client and server. When I mean tightly coupled, it's very purpose built and hence tightly coupled from my opinion. There's still limited browser support. The way I understand it is you cannot force browsers to send out an HTTP2 request. I think that is my understanding of the limited browser support. So if you still want to use gRPC on browser-based apps like Blazor or something, I think you need to have gRPC Web. It relies on HTTP2. That's one of the negative points because I don't think all of the browsers even now support HTTP2 fully. If I'm correct, there's zero discoverability. The protofiles cannot be replaced for good documentation. So you need to have something in black and white as your documentation. And the nucleus of gRPC, which is functions, can actually go against it. And you can easily have function explosion with millions and millions of services and functions in place. And finally, the protocol buffers are not human readable. They are in binary format. So with that, let's wrap up gRPC and then talk more about the next API pattern, which is REST. REST is by far the most popular API design pattern, and it is well adopted and very successful. And REST stands for Representational State Transfer. Sorry, Santosh, did I hear anything?
No, sorry. If you are not on mute, to the audience, please mute yourself.
Cool. I'm continuing there. So REST stands for Representational State Transfer, and it was first presented by Roy Fielding in his famous dissertation in 2000. He presented REST as an architectural style for distributed hypermedia systems like Internet. REST is by far not a standard or a spec. It is all about top-level guidelines, which tells you how you should architect for a distributed hypermedia system. It leaves the implementation details to you. So you are at the freedom to implement however you want it. REST is a set of guidelines that it can give you with. The fundamental unit of REST is resource. It is all about modeling resources, collection of resources, acting upon resources, relation and links between resources. And a resource is something or anything that can be named, like a person or a vehicle or a vegetable, anything that can be named is a resource, or anything that the author can click through to on a page, that is a resource. That's how I understand resource. So REST basically says, here are some resources and here is what you can do with them. And for every resource, there is also a resource identifier, which is a unique way of identifying a resource. This, in fact, is one of the constraints of REST as well, which we will talk about. Whenever you interact with a resource, you are actually interacting with a resource representation. So I, as a developer, I give a resource representation to my API, and I get back a resource representation from my API. And that representation is made up of data, that is the information, the metadata, and the hypermedia links. So when I mean about data, say I have this user called, with the ID one called Harry Potter, and there's a headline. And we have certain hypermedia links as well, which says how to get the information about the resource, how you can update the resource, or how you can delete the resource. These are the hypermedia links that we are talking about. And there is the metadata. That is the response metadata that is coming back from the server for me. REST at its basic gives you 6 constraints, and these 6 constraints, when implemented and when adhered to, you have a RESTful system in place. The first one is client server, which means that there's a client which asks for information and the server uninterruptedly provides that information. There can be any number of clients, and client and server communicates through a request response pattern. It should be stateless. So every request that goes from a client to the server must be stateless and should be independent of any request that came before it or any request that is about to come after it. So which means that any session management happens solely on the client or intermediaries. It can never be on the server. The server should not maintain the state at all. Cacheable. So note that cacheability is the constraint here, not caching. So if you have a response, you can mark it cacheable. And such responses can be then served for equivalent requests from the client. That is the constraint here. And the caching can happen on the server or on intermediaries or on client as well. The most important REST constraint is about the uniform interface, which means that there should be a unique, uniform way of identifying resources. And this is then further controlled by 4 sub-constraints, which is identification of resources, which means there should be a unique, uniform way of identifying a resource, for example, through a URL or something. There should be, you should be able to manipulate the resources in multiple formats. So you could have JSON, XML, text, HTML, all as ways of representing a resource. The messages should be self-descriptive. That is, everything that goes in should contain all the information to execute that particular request, and everything that should come back should have all the information that it needs as well. And the final constraint is HATIOS, which we will talk about later on, and that actually is the glory of REST. The next one is layered system, which means that any RESTful system can be made up of multiple layers, and each layer should be independent and should talk only to one layer above or beneath it. And layers can be easily replaced or taken away as well. So if you have a big system, it is made up of a set of layers, each doing its own purpose. And these are the 5 mandatory constraints of REST. The last one, which is code on demand, it is an optional one, which says you can have things like applets served back as well as a part of your response. With REST, I think there are some myths in place as well. Say, for example, if you serve JSON over HTTP, that is REST. That's so not true. Just because you serve JSON over HTTP, that is not REST. REST constraint doesn't talk of JSON anywhere or HTTP anywhere. So just because you have JSON or HTTP doesn't cater you in for a RESTful system. RESTful system must always adhere to the 6 constraints that we spoke about. As developers, sometimes we start off with having the wish to design the best RESTful API in the world, but soon it actually breaks through partway, and then that becomes RESTful procedure calls or invoking methods over HTTP. Again, not REST. But you can find examples of this as well, because REST is, again, not a standard. You would have APIs out there which have fine-grained resources, as well as a mixture of these procedure calls as well. And the biggest of it is that REST equals HTTP, which is not true. REST is an architectural style for distributed hypermedia systems like the internet, which runs on HTTP. Roy Fielding was associated with the HTTP RFC, and he was the one who presented REST. So you would find similarities between the two. REST was put in place to standardize web, which runs on HTTP. So Roy Fielding was of the opinion that something like REST can be well suited for HTTP, and it is therefore easier to implement RESTful systems using HTTP. And to do that, it uses what HTTP provides you as a toolbox. So all the request headers, caching, authentication, the HTTP verbs, they are all part of the HTTP toolbox. And with a RESTful API, we are reusing what HTTP provides us with. So there's a seamless integration between REST and HTTP. What an API with with a REST API would look like is a root entry point, say api.xyz.com. And from there on, users can use the hypermedia links that come as a part of the response to navigate through the API and then figure out what more they can achieve with the API. So if you imagine a collection of links making up a web page, a collection of web pages making up a website, that is exactly how the API is supposed to be as per REST. It's, again, something in ideal circumstances that we can strive to achieve, I think. And what would the endpoints, how would you act upon the API, the CIOD operations? You would issue HTTP verbs to a unique URI, and then you would get statuses from the API as your responses, along with the response body, obviously. So for example, you would issue a HTTP GET verb to a URI that is /users to get a list of users, or to /users providing an ID to get a single user by their ID. But note that the root URL doesn't change here. That is /users. It's a unique uniform URI for your resource. If you want to create a new user, you would issue a HTTP post um, request to, again, the same endpoint, that is /users. To update a particular users, you would issue the HTTP put verb and to the same URI passing an ID. And to delete a user, you would again have an HTTP delete verb issued to the /users endpoint or the resource, passing it an ID. So in reality, what is REST is that URI that you see there. That is the constraint from REST. The REST, that is the HTTP verb, request body, response body, status called is, it's all HTTP toolbox that is getting reused by the RESTful system. And if you were to extend the system, would you be using something like this, say get stories for user, get stories for comments, etc.? Nope, that is not the case. This is what my second myth was all about. REST becomes RESTful procedure calls. So not the case. This should not be where you should be aiming for a complete RESTful system. What you should be aiming for is Hatios or Hypermedia as the engine of application state. This is REST glory, REST nirvana. Till now, what we were talking about is HTTP API. And what makes an HTTP API completely RESTful is the implementation of Hatios. So the primary motivation of RESTful API is that, as I said before, you have a root endpoint. Users can actually click through the hypermedia links, understand what more actions you can perform on a resource, what other resource are linked to a particular resource. All this happens with a single HTTP GET request issued to a single resource. And the user then navigates using those hypermedia links that are provided. And this principle is called as Hatios. And this was mentioned, or this was coined as the highest level of REST by Leonard Richardson in his concept called Richardson Maturity Model. So Richardson Maturity Model is a concept which is a measure of how RESTful or how mature your system is as a RESTful system. And it is at level 3 when you introduce hypermedia controls in your responses that you have a completely RESTful system in place. So at level 0, we start off with RESTful procedure calls, that is issuing calls over HTTP. At level 1, you start to think about resources, but everything is again using HTTP post. At level 2, you start issuing HTTP verbs to your resources, which we just spoke about. And at level 3, we introduced hypermedia controls, which is where we have the glory of REST. So there is a write-up by Martin Fowler about this. I highly recommend reading that to understand all about Richardson maturity model. So feel free to go and have a look. I think it's the first search result that you get back when you type in Richardson maturity model in your search engine. And this is how the response would look like. You would have the information about what you asked for as a resource, plus the information on how you can act upon that resource, say how we can get the information, update the information, delete that particular resource, or even get related information. That is, a user can have stories, and how you can get to that resource. That is the linked resource, that is stories in this case as well. But for now, we don't have a standard as far as hypermedia links and the responses are concerned. HAL is a work in progress standard convention, but it's no longer like a standard. And 2 MIME types were suggested, application HAL XML and application HAL JSON. But I think the initial draft of this convention or standard has expired as well. But these 2 are the suggested MIME types for implementing HAL. And when I started looking at this, in a code base, even I was kind of lost. Like, is this the right way to implement this? No one says about how to implement, or this is the right way to implement it. Every developer has their own take of implementing REST. And that all comes down to the fact that REST is not a standard or a spec. It's a set of top level design guidelines. Talking about advantages and disadvantages of um, REST, we have decoupled client and server, which means the client and server can evolve over time. That is what is envisaged with REST. It's scalable, there's seamless integration and reuse of HTTP. It's easy to consume, and there's superior browser support. It can get chatty. There is no single spec. You can have big payloads with REST, and you have this problem of overfetching, underfetching, and N+1 problem. Overfetching means I get a lot of information, use a part of it, and then discard the rest. Not very green. Underfetching means I don't have all the information that I need at any point of time. So I go and fetch more information. So again, overfetching and underfetching goes hand in hand. And for every call or um, everything that I have to retrieve back, I make N+1 calls. So these three problems actually paved way to the very existence of GraphQL. GraphQL was introduced as something new to, or an answer by Facebook for their very panned mobile app in the beginning. And GraphQL is actually a query language for APIs. So unlike REST and gRPC, which are like systems APIs, GraphQL is a query language for APIs. And the server actually supports a runtime for understanding these queries, parsing it, and executing this. But most importantly, GraphQL sits on top of your existing data. So it's a query language. There's a runtime for understanding these queries, but these queries act upon your existing data, which can be like a database, it can be a REST API, it can be sourced from multiple endpoints, like a collection of GraphQL endpoints as well. So with GraphQL, you are talking about query languages. And at its very basic, GraphQL is all about specifying types and asking for specific field on those types. So if I have a user is a type. Story, again, it's a type. I cannot say, hey, GraphQL endpoint, get me the user with ID 1234 and all the information about that particular type. I cannot do that with GraphQL. I need to specify what I need from my GraphQL endpoint and for that particular type. So it's very, hey, tell me what you want and I'll give you that. So it's like a smart person in between you and your API telling you, tell me what you want, where you want it from. I'll get that for you. And that is what exactly GraphQL is. It's a single smart endpoint. That's the most important thing here, which takes in complex queries and builds the data output. So when I say build the data output, if you see the screenshot here, on my left-hand side, I have my query. I'm asking for a course of ID, say 1045. I'm asking for certain fields on it, say ID, credits, and title. And I'm also asking for related information about the course. So the enrollments might be a separate, different entity altogether, but with GraphQL, it understands your data hierarchy, and I will be able to ask for related information, that is student enrollments. And what the endpoint brings me back is data, which is in JSON. I get the exact same thing that I asked for. I don't get anything more than what I asked for. But most importantly, the shape of the data that I get back is a mirror image of my query. So as a client or a consuming developer, I can specify the shape of the data that I need, and the server responds back with the exact same data graph as the query. So which is predictable information. And with GraphQL, the nucleus is query because the result that I get back varies according to what my query is. I ask for data, I get back the data in the same shape, and nothing more and nothing less is retrieved as well. So there's exact fetching. Some of the features about GraphQL, it's strongly typed. It's a specification, which means the various servers of GraphQL across various different programming languages tries to stick to that specification and implement that specification. It's introspective, which means a GraphQL endpoint can query and understand itself. And this is quite a unique feature, which has given rise to self-documenting GraphQL endpoint. So if you have like an ID to test your GraphQL endpoint, you will have documentation which it gathers with its introspective nature. It's hierarchical, so GraphQL accepts or understands and respects your data hierarchy. And if you visualize your data as a graph, GraphQL helps you extract parts of that data graph, which is why it is called GraphQL. What you get back from the server is a JSON response that mirrors the query. GraphQL is an application layer, which means it is all about understanding your query, executing it, and giving the shape that you need. It doesn't concern itself with where your data is stored. GraphQL is version free, you can call it, because the client is in more control of what they want from the server. And in such instances, even if I, as the server developer, adds a field to the response, it is business as usual for the client till the client consumes that. So it's literally version free. But then there are ways to break it by, say, changing the nullability of something that comes back, or changing or getting rid of a field entirely. But then there are ways to come over it as well. So you could say that GraphQL is version free. And finally, GraphQL is transport layer agnostic, but HTTP is the most common way of consuming it. We talked about GraphQL being strongly typed, and schema is what gives that strongly typed character to GraphQL. It is the heart and soul of every GraphQL endpoint. So with your schema, you have your types. The first one being the object type, which is a representation of your object, say user or story or comments, etc. Then you start having your operation types. The first one being queries, that is to get the data or read information, mutations to insert, update, or delete data, and subscriptions for the pushed updates. So a schema is made up of types, and these types can be your object types, that is a representation of the object, or your operation types, which is queries, mutation, and subscriptions. And each type, be it object type or your operation type, they are made up of fields. Each field has a name, a scalar or a complex type, that is the type of the field, and a resolver, which tells you how to resolve the field to the concrete data. So if you're thinking of your object type, say user, you could have an ID, a name, and a headline as the field. If you're thinking of your query operation type, you would have fields there to say, get all the users or get a particular user by its ID. You could have a mutation, and the fields could be like insert a user, update a user, or delete a user, and so on. So be it operation type or object types, they are made up of fields. Let's talk about each of the types in a bit more detail. The first one being query. This is one of the operation types in GraphQL, and it's a top level entry point for read operation. It is used for getting or fetching the data. And unlike REST, where you read over a HTTP GET request, we ask for specific fields on objects using a POST operation. The keyword here is query. It's not needed, but it's best practice to include that keyword in your GraphQL query. If you don't specify the keyword query, it is understood by default that what you're writing is a query, because every GraphQL endpoint at a minimum would have query operation types, not necessarily mutation and subscriptions. What you get back again is hierarchical JSON response. Talking about mutations, that's the top level entry point for write operations using HTTP POST. The keyword for your queries would be mutation. And unlike queries, mutations always accepts an input type as an argument. It's a special GraphQL type again. You have subscriptions, which stands for pushed updates from the server. Unlike the client polling, this is updates pushed from the server, and clients can choose to listen. Normally works over WebSockets and uses HTTP POST. The keyword here is subscription, and unlike mutations and queries, subscriptions are stateful, so it has got an understanding of what came before it as well. Now, how does the API look like? We spoke about the operation types and operation types having fields. So my query operation could have users and user as fields to read information about all the users or about a particular user. The mutation could have a create user, update user, and delete user. Subscription could be an update to all the subscribed clients whenever user is added or updated or deleted. It's up to you what you want to do with subscriptions as well again. Now, how can the queries look like? Say, for example, if you want to read all the users, this is how we would suggest it. If you want to query a single user, adding a user, updating a user, deleting user, subscribing to user, note that what follows after the keyword is arbitrary names that I give. Certain queries like the single user has an argument. The mutation takes in the input type. Updating and deleting, again, being mutation takes in input types. But this is how queries would look like. And if you want to have additional information, that is related information about users and the stories, you could fetch that alongside your all users or your single users. You could say users ID, name, headline, then stories, you could say ID, story likes, the story headline and description, etc. So whereas we need to do some work with gRPC and REST for the related information, GraphQL is smart enough to understand the data hierarchy and helps you query the related information as soon as you have your setup ready. Now, some of the advantages and disadvantages with GraphQL, you have exact fetching. You get what you ask for, nothing more, nothing less. There's loosely coupled client and server. There's auto-generating API documentation. It's literally version free. But where it has some negatives is the caching complexity and file uploading complexities. You can have a performance hit with complex queries. Again, with GraphQL, the learning curve is a lot more when compared to gRPC and REST. And finally, it's still a growing community. It is certainly gaining traction. It is one of the cool kids on the block when it comes to APIs. There's some magic happening, but it's still a growing community, I feel. Now, for the comparison, let's see what the comparison stands like. So the fundamental unit with REST is resources, with GraphQL it's query, and with gRPC it's functions. In terms of coupling, that is client to server coupling, REST in GraphQL has low coupling while gRPC has higher coupling because it's purpose built. REST is very chatty. gRPC is medium in the level of chattiness and GraphQL is low on chattiness because you ask for something and you get just that. HTTP caching is made use of in REST, while as with GraphQL and gRPC, you would have to do custom caching. Discoverability, REST, provided you have Hatios implemented, you have good discoverability. GraphQL, because of its introspective nature, the minute you have something like a GraphQL playground, you have auto-generated documentation for you, so good discoverability. With gRPC, you have to have something concrete in place. Versioning can be needed for REST and gRPC, whereas GraphQL is considered no versioning. With performance, GraphQL can suffer on complex queries. REST and gRPC is good. Payload size is very heavy in REST. With GraphQL, it can get medium, whereas with gRPC, owing to protocol buffers, it's lightweight and the minimal size. Payload format, let's keep it as JSON in REST or XML, but it can be text, HTML, anything in REST. With GraphQL, what you get back is JSON. With gRPC, it's binary format. Browser support with gRPC, I think it requires gRPC Web, which does a translation from HTTP 1.1 to requests internally, whereas with REST and GraphQL, there's browser support. REST is only best practices, whereas GraphQL and gRPC are formal specifications. The protofiles are a formal spec, and you should adhere to that. In terms of maturity, REST is very mature. GraphQL is still early. gRPC is still early, I think. Learning curve is the highest on GraphQL, whereas it's medium with REST and gRPC, especially when it gets to the Hatios point, it starts getting, it can get a bit heavy on the learning curve with REST. Learning resources, you have lots of resources in REST, whereas there are fewer compared to REST with GraphQL and gRPC. .NET support for REST is out of the box, gRPC is out of the box. With GraphQL, you are relying upon third-party implementations. I think as of now in .NET, you have two implementations, GraphQL.NET, which has been out there for some time. And then there is Hot Chocolate, which is the server from the house of Chili Cream. Both are open source, so if you are interested in contributing to open source projects, feel free to check them out. There's Visual Studio support for REST and gRPC out of the box, whereas with GraphQL, you need to rely on external templates. I think Hot Chocolate has a Visual Studio template which you can install and start using. And when it comes to hosting on Azure, REST and GraphQL can be hosted on App Service and Azure Functions, but I think gRPC requires Azure Kubernetes Service because App Service still doesn't support HTTP2. I don't know whether that has changed, but the last time I read it was the case. Some tools to test your APIs with REST, Swagger UI. You have Postman, command line, you have REST client, Visual Studio Code extension, which you can use to create HTTP files and then issue requests. For GraphQL, you have playgrounds like GraphQL Playground, Insomnia, Banana Cake Pop. Some of these are browser-based, some of these are standalone. Banana Cake Pop, again, is from the house of Chili Cream, and they have a standalone version as well as a browser-based version. Good tools to test your GraphQL queries. With gRPC, you have the command line that is gRPC curl, and then you have gRPC UI, which actually uses gRPC curl underneath the hoods. And you have Bloom RPC, which is similar to Postman here, but I haven't used it. gRPC UI is good. It's quite easy to integrate and then start using as well. With the use cases, REST is ideal for management APIs where you have clearly defined resources and you act upon the resources. Things can go a bit awry as well if you have much more complex scenarios. So then you might need to settle in for a mixture of CRUD upon resources and a mixture of scenarios like get me this, get me that. And I think GitHub API is one of such use cases as well. You can have varied client usage. So if you have varied client usage, like mobile devices, websites, etc., REST can help because anything that can issue an HTTP request can consume REST APIs. Again, microservices, a perfect use case for REST. GraphQL is made for mobile. So wherever you have mobile devices, try and use GraphQL. It's a win-win situation where the data is like a graph or relational or where data needs fetching from multiple APIs. Again, GraphQL can help. gRPC is favorable to where you have action-oriented APIs, typically for internal services or even microservices. It can be of great help in IoT devices, I hear, and even in polyglot environments where you're using multiple programming languages. So that is a little comparison of the 3 API patterns and some additional information for you. That is all my resources for the day. So I've put together a collection of resources which I used to research on this topic. I can share that with you in the Teams chat. But I hope you have learned something today, and thank you once again for having me as a speaker today, and a good day to everyone wherever you are.
Hi, Poornima. Thank you. Great talk. We do have a few questions, so I will try to read them out, and if you can answer or point us in the direction of some resources, that would be great. So the first one is from Siegfried. They're asking, how does gRPC deal with issues like big Indian versus little Indian? So that's the whole thing about how the CPU, arranges bits and bytes. So, if client and server are both little Indian, will it optimize by transmitting little Indian, or does it take the performance hit to convert to text and reconvert it? So the rest does the reconvert, and it takes the performance hit. So that's one question we have.
I must say this is a bit beyond my knowledge, but what I understand from the tooling is that it converts it into corresponding .NET types. I don't know what happens at the CPU level with it, but as far as I understand, the tooling takes care of the conversion for me. I don't need to do anything further more than that. So this is something that you would need to require to look into the tooling, I guess. It's a little bit beyond my my knowledge.
Sure, and I'm actually reading the protobuffer documentation for Google, and at least the fixed 32 bits, it talks about encoding as 4-byte little endian. So hopefully that is a place that people can refer to for those answers. Okay, so the next question is again from Sigfried, and question is REST is stateless. What about gRPC? And I'll add to that, what about GraphQL?
GraphQL, as I said, is stateless with query and mutations. When it comes to subscriptions, it gets stateful, as I said. There is a good comparison of gRPC versus REST in the Microsoft Docs as well. So I would highly recommend reading through that as well. I think gRPC is stateless as well, because once you get the request and you forget about it, the server takes care of it. So yeah, that is what it is.
Okay. Next question is actually from me. You have upsert operations in modern database systems. So basically that means when you send something, it'll either insert or update it. So that's why it's called upsert.
Yeah.
So what is your recommendation for how to do them in REST? Would that be a put or a post?
Okay. I'm going to take the post way, because we know clearly that whenever I'm supposed to create something, I need to do a post. So I'm going to go the post way and then let the server handle it for me. But ideally, yeah, upsert is the way these days, isn't it? We don't normally do updates and then inserts. Yes, for upserts, I generally stick to post rather than put. So definitely that's the way.
And then next question was from Greg. Hey, Greg, long time no see. Excuse me, as I'm hearing an echo. Which hypermedia format is shown in your slides? Is that
good one? It's plain old JSON. I haven't stuck to HAL for the time being. The reason being, when I started researching about it, I had the same confusion. Should I stick to HAL XML or should I stick to plain old JSON? Actually, it's my own implementation, so JSON is fine. So that is the way I took. This information actually is from a book by Leonard Richardson called The RESTful Web APIs. There's a whole chapter dedicated to HATIOs in it. So that's where it talks about HAL XML and where I got the information from, but I haven't used it personally. It's plain old JSON that I'm using as the MIME type here. But then you can issue headers and then change and manipulate the resource the way you want it as well. So I saw that as a demo somewhere, but mine is plain JSON that I'm using. It's, as I said, REST is not a standard. It's design guidelines. You choose the implementation of it. And as long as that is implemented, that is REST for you.
okay? Thank you. Tony says, seems like the industry has forgotten about OData. Do you have anything to add in terms of OData and what we discussed today?
Oh no, I haven't played around with OData at all. I know it's it's all about filtering of data, I guess, and it's a very different take on things. But I don't know whether OData is necessarily an API pattern. As far as I understand, it's about how you retrieve the data from what you have through filtering. But no, I haven't played around with OData at all. No.
Okay.
Yeah, GraphQL is definitely not OData. It's two very different things. Yeah, app service does support HTTP too. Yes, so that's why I said I may not be correct about that.
Yeah, I think Tony says you must turn it on by configuration.
By configuration, yes.
Yep. It supports WebSockets. That is correct. App service does support WebSockets. Then Greg added a link for different general purpose 8OS and hypermedia formats. So definitely what I'll do is I'll take some of these links and share them. Jesse has a question. What is the performance when you want to send files? When one can connect to a stream of a HTTP GET request and send bytes, while gRPC has to encode the bytes and send them. Or comparing gRPC to streams provided by WebSockets.
That's a good one. Yeah, it has to make all that effort to encode it and then send it as well. So there could be some interesting factors there. I haven't personally tried it, but I do see the point there. It's one to investigate, I guess.
Okay. Any other questions from our audience? We'll give it a minute. If not, we can call it a day. And what I'll do is I'll stop recording. This recording will be